In section 4 here, we're going to continue our discussion of transformations, and specifically today we're going to focus on rotations. And again, we've discussed this a little bit in first semester, not to the degree that we're going to get into now. We're going to look at actually coordinate rules and how to rotate things instead of just, in first semester it was mainly, hey, identify the rotation, okay, and is it 90 degrees, 180 degrees, or 270 degrees, clockwise, counterclockwise, okay? So the first thing to note is that rotations of a positive magnitude, okay, rotate counterclockwise. So if I say rotate 90 degrees, positive 90 degrees, that means you're actually going to rotate counterclockwise, okay? If I say rotate, let's just say negative 180, although 180 is kind of a moot point, but if I say negative 180, that actually means rotate 180 degrees clockwise. However, if you do recall from first semester, 180 clockwise and 180 counterclockwise are both the same thing. Okay, so with 180, the magnitude doesn't really matter. And then finally, a rotation is an isometry. Okay, in other words, when you rotate a figure, the original figure and the new figure are both going to be identical. Okay, same exact size, or congruent. Alright, so here are the rules that you're going to need to know for rotating. Okay, if you want to rotate, one thing to note here is that these rules are used for rotating counterclockwise. Alright, so if I say rotate 90 degrees clockwise, you're going to have to think about that in terms of counterclockwise, and remember 90 degrees clockwise is the same as 270 counterclockwise, so you're going to have to do some backwards thinking a little bit there in order to do these. So if you want to rotate 90 degrees counterclockwise about the origin, then your coordinate rule is you take your original coordinates, you flip-flop them, and take the opposite of the first one. Okay, so flip-flop and then opposite of your new x value. For the 180 degree rule, again, counterclockwise, you just take the opposite of both coordinates. The opposite of A and the opposite of B, okay, or the opposite of your x value and the opposite of your y value, and that's your new point. For 270 degrees, it goes right along with the 90 degree rule. You're going to flip-flop them, except now you're going to take the opposite of the second value, of the y value. And the 360 degree rule isn't really a rule because if you rotate 360, hopefully it makes sense that you end up right back where you started, so you don't really do anything to your coordinate. It's the same. It's just going to be A comma B. So again, those are the three primary rules you're going to have to know for this section. If you have that down, then really you're going to understand the section pretty well. Okay. Alright, this is exactly what we just said. Now we're getting into matrices a little bit. So again, if you're in my regular geometry classes, you're going to have to kind of sift through some of these notes. When they involve matrices, you're not going to have to really work through those. Okay. So I'm going to do this a few different ways. I'm going to do this using matrices, and then I'll do it using coordinate rules. Okay. So it says the pre-image matrix. Okay. In other words, the matrix before. Okay, so what you do is you put your quadrilateral in the excuse me. You put your quadrilateral in the matrix here. So 3, 1, 5, 1, 5, negative 3, and 2, negative 1. And then it says rotate 270 degrees about the origin. So we use our 270 rule, and so if I'm just using coordinate rules, all I'm going to do is I'm going to flip-flop them, and then remember I take the opposite of my new y value. So when I flip-flop them, I get 1, 1, negative 3, and 1. I'm sorry, negative 1. And then my y values are going to be 3, 5, 5, and 2. And remember the 270 rule says take the opposite of your new y values. So negative, 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 negative. And so that would be your image matrix right here. Okay. If I were going to do this just using coordinate rules, then what I would do is I would take R, and since I'm going 270, I would take R, I would take the point 3, comma 1, and that would go to the point 1, comma negative 3. Okay? I would take S, if I'm going 270, I flip-flop, and then opposite of my second one. Flip-flop, opposite of the second guy. And then again, the last one over here, flip-flop them, and then opposite of the y coordinate. All right, so again, regular geo students, you're going to have to know these coordinate rules right here. This is all I'm going to expect from you. Okay, you're not going to really have to work with matrices at all. So you should just be able to identify, okay, if that's my point, and I want to rotate 270, I flip-flop, and then take the opposite of my new y value. Okay. Number 2 here, my suggestion would be to again, try it on your own, see if you got it, and then we'll go from there. Okay. So depending on what class you're in, if you're in my honors class, you're going to probably want to use matrices, so -3, 2, -3, 4, 1, 4, and 2, 2. I'm going 180. 180 just says take the opposite of both coordinates. So the top row is going to now be 3, 3, -1, -2. And the bottom row is going to be -2, -4, -4, -2. All right. Again, regular geo students, okay, you should be able to do this. So E is -3, 2. I take it to E prime, right? Opposite of both, so 3, -2. That's where that comes from, okay? And then F is the point -3, 4. And so when I go to F prime, I get 3, -4. G, 1, 4. Since we're going 180 degrees, G prime says to take the opposite of both, so -1, -4. And finally, let me just scroll down just a little bit here, give me a little bit more room. And then H is the point 2, 2. And so H prime is going to be, H prime is going to be the point -2, -2. So again, just know the coordinate rules. You just got to study them, memorize them. All right. So now we're still using the same quadrilateral that we just had, so I'm going to have to go back and rewrite this. So EFGH. So, let's see here. EFGH, so E is -3, 2. So, I'm just going to write the coordinates up here. -3, 2. Let's see here. -3, 4, and 1, 4. So, -3, 4, 1, 4. And the last one was 2, 2. All right, so I got to use those to find the image matrix after the rotation about the origin. Okay, so again, if you're in my regular geo classes and you want to watch this just to kind of get some more insight, that's fine. If not, that's fine too. Okay, so I go through and it says if I rotate it 90, okay, if I rotate 90, remember that means flip-flop and take the opposite of the first ones, or of your new x coordinates. So when I flip-flop these, let's see here, top row is going to be 2, 4, 4, 2. Bottom row is going to be -3, -3, 1, and 2. And then I got to take the opposite of the top row. 270s, exactly the opposite. Flip-flop. So I'm still going to have 2, 4, 4, 2. And then you take the opposite of the new y value. So 3, 3, -1, -2. And then obviously 360 is going to be the same thing, okay? So it's not going to rotate at all. Well, I shouldn't say that. It does rotate, but it ends up in the exact same spot. All right? And then we end up with, let's see here, 2, 4, 4, 2. All right? So that's all we're doing. And again, you guys can go ahead and graph those on your own. I'm not going to take the time here to graph them. It's just plotting points. So again, any questions you have on rotating figures, make sure you bring those to class tomorrow, and we'll go from there.